Jake is skipping stones on a pond. Each time he flings a stone, he counts the number of times it skips over the water. The number of skips he recorded for each stone were, and here's all the numbers. The question is, which measure should Jake use to calculate the difference of the highest and the lowest number of skips? So, you selected interquartile range, which the interquartile range would be all of the values between the 25th and the 75th percentile. So we're kind of leaving out the numbers to the two sides of the range here. That's not the correct answer. So let's talk about the other answers. The mean absolute deviation would be how far things deviate from the mean. We haven't calculated the mean, but we could go through and figure all that out, but that's not the correct answer either. The mode would be the most frequent answer, and so let's see, maybe it's 3. There's 1, 2, 3, 4 threes. I think the mode is 3, but that's still not the difference of the highest and lowest of the numbers. The range, the definition of the range is the difference of the highest and the lowest number in a set of data. So the answer would be D, range. So when we think of the range, if these were ordered on a number line or from lowest to highest, then the range would be talking about how wide of a set of values do we have. So if you think of it that way, for example, if you had a number line that was listed 1 to 10, you would know the range by taking the highest value, 10, and subtracting 1 from it, and the range would be 9, which means we're not considering 0 and we're not considering 11. We're only considering 1 through 10. So in this similar way, we would find the range by calculating the difference of the highest and the lowest number of skips. So the range in this question would be the highest number 5 minus the lowest number 1. The range would be 4. So that is the range that we're considering. E is the mean. So the mean would be you add up all of these numbers and then divide them by the number of data that you have. So I did not even count how many data there are, but we can. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so there's 15 times that he skipped and recorded the number of skips over the water. So we would just sum these all up and divide it by 15, and whatever you get would be the mean. But the correct answer in this case is range, because range is the difference of the highest and the lowest number in your data set, in this case, skips. The next question here is, the weights of 5 girls are 70 pounds, 68 pounds, 85 pounds, 62 pounds, and 70. Nina finds measures of center and measures of variation of this data. Match the descriptions to the type of measure. I noticed on this question that over here you wrote measure of deviation. I think you meant to write measures of variation because that's what you have up here. Okay, so you want to know which one is a measure of center. So I'm going to bold that. And which one is a measure of variation. And so I'll just delete these. She found the middle value after arranging all the values from least to greatest. So when we take these numbers and we arrange them from least to greatest, the middle value is the median. The median is a measure of center. She added all the values and divided by 5. Well, there are 5 values, and we know when we find the mean, we would add up all the values and divide it by the number of values. So if she added up all these values and divided by 5, what she found is the mean. And the mean is a measure of center. She found the difference of the upper quartile and the lower quartile. Well, here's a little hint. Anything that has to do with deviations, quartiles, percentiles, or anything like that is always a measure of variation. So since she found the difference of the upper quartile and the lower quartile, she's finding a measure of variation. She found the value that appears most often. The value that appears most often would be the mode, and that's a measure of center. She found the mean and then found the average deviation of the weights from the mean. So the mean is a measure of center, but then she found the average deviation of the weights from the mean. So when we talk about the deviation of the weights from the mean, we're talking about a measure of variation. So don't be thrown off that she found the mean, because you need the mean in order to find the average deviation from the mean. So this is a measure of variation. And then last one, she found the difference of the least and the greatest values. And just like in the last problem, when you find the difference of the least and greatest values, what you found is the range. And the range is a measure of variation. The next question, Ella surveyed a group of boys in her grade to find their heights in inches. The heights are below. You can see that we have a really large list, so I won't read them all out, but you can see them all right here. The question states that we are to create a histogram that correctly represents the Dadoes. So on the x-axis, what we're graphing is boys who are 56 inches to 60 inches, boys who are between 60 and 65 inches, and then 65 and 70, and then 70 and 75, and then 75 and 80. So in order to create this graph, a histogram is basically a bar graph that is going to help you to see how dispersed these boys' heights are. So we want to find all the values in between 56 and 60. So to do that, we have to go up here and we have to just go through and count them. So just kind of use your eyes and scroll through. Here's one, 57. Here's another one, 56. So that's 2. It looks like we have 2, just 2. So when we're making a histogram, here's the 2 and here's the 56 to 60 range. When you make your bar graph, you would make it go up to the 2. So this area that I'm using my cursor to show you would be how tall it would be. So the next range of boys that we need to measure is 60 to 65. So we would do the same thing, find all the values between 60 and 65. Here's one, 63, 1, 2, 3, 4, 5, 6, 7, and 8. It looks like there's 8 boys who are between 60 and 65 inches tall. So on this one, your next bar would go all the way from the 0 all the way up to the 8. So if I were actually drawing it in, which I'm not because I can't do it right in this program, but you would make your bar all the way up, and then you would do the same thing. So what you usually find in a histogram like this is you would usually find that you see some sort of a bell curve. So it would start lower, and then you would peak out somewhere, and then start to go back down again. So the rest of them, I'm sure you could do on your own.